Okay, it's time for your Friday video. Now what we're going to be doing in a minute is we're going to continue talking about inverse functions. But kind of before we do, let me kind of reiterate your projects on Moodle. Um, you should be able to get a copy of it. You need to start working on it now. You don't want to wait till the last minute because, something could go wrong. Wi-Fi could go out. You could get sick. We don't want to wait till the last minute. If you have questions as you do it, you are free to email me or come see me or call me, make an appointment. I'll be happy to look it over, see if there's anything that you need to change or needs improving. But remember, it's due Monday, October the 19th. So that's not Monday, it's a week from Monday. In other words, when class starts, you have to give it to me. So it's due at the beginning of class. So you can't come in late and then hand it to me or it's going to be late. Okay, so it should be 30 points that you can get that should help your grade. And then remember, your test is going to be a week from Friday. So it's going to be October the 16th. So you'll have your test on Friday and then your project's due on Monday. Okay, so I put up on Moodle already what sections it covers. Basically, out of chapter 2, it starts with section 2.2 and goes through section 2.6. So linear equations are on there. So you've got to be able to write equations of lines. You've got to be able to find slope. Remember, you need two things to write the equation of a line. You need point and slope, okay? Remember that all vertical lines have the same form, x equals some number. That's the only time that y minus y sub 1 equals m times x minus x sub 1 formula will fail you when you want to write the equation of a line. Okay, so usually you get a point and a slope and you substitute into that formula. Okay, then you've got to be able to tell if things are parallel or perpendicular. Remember, if the slopes are the same, they're parallel. If the slopes are opposite reciprocals, they're perpendicular. Okay, then you've also got to be able to do kind of some linear modeling and that direct variation. That was a Friday video for you. So it's still out there, so you should still have the link. If you don't, email me and I'll send it to you again. Okay, so it should be public, so you can just go look on my YouTube channel and find it as well. Okay, so if you've forgotten how to do those kinds of word problems, then kind of go look that back up. Then we did functions. So remember, a function means one thing in, one thing out. What's going in is the domain, what's coming out is the range. So I might give you a function and say, find me the domain. Remember, when you do that, there are two trouble spots: even powered roots and fractions. So if you've got a fraction where the variable is, remember, you take that denominator, that bottom, and set it equal to 0. And then you solve it, and your domain's everything but those answers. Okay. If you've got an even powered root, remember, you take the radicand, that's that stuff under the root, and you set it greater than or equal to 0 and solve it. And that is your domain. That answer is your domain. So for what we're doing right now, if you don't have an even powered function and you don't have an even powered root, and you don't have a rational function, in other words, a denominator where the variable is, then your domain's just all real numbers. Also give you like a list of points and ask you, could these be a function? So remember, you can repeat the y coordinates and be okay, but you cannot repeat the x coordinates. So if the x coordinates repeat, that's not going to be a function. Then I'll give you some functions and ask you to evaluate them, like find me f at 3. So you would substitute 3 in for x, or find me f at a plus 1. So in place of x, you'd put a plus 1. You also had some of those piecewise functions where, part of it would be one thing and part would be another thing. So you had to check the number that you were substituting in to see which piece to put it in. So you should have notes on that. And then I'm going to ask you to graph some functions, those basic functions. So remember, you've got lines, parabolas, absolute value, the square root, and that cubic, so that S-curve. And then we talked about, the translations, what would happen if you took that x squared and you added 2. So that parabola gets shoved up 2. So go back and look over all that, and then that finance that we've been doing in the last week and a half. So make sure you know those formulas, the one for simple interest, the one for compound interest, and the one for payments. Okay, so part of your homework is going to tell you to start kind of studying for your test. All right, So after you watch this video, do your homework on this, but this is not going to be on your test on Friday next week, okay? So let's share the screen and see if we can get it to work. Let's see if it's going to be a good day. All right, here we go. So we're talking about inverse functions. Now I was going to kind of reiterate what we were doing today in class because we went over at the very end and we were going kind of fast. So this is your definition of inverse functions, okay? Inverse functions, two functions like f of x and g of x are inverse functions if and only if f composed with g of x ends up being just x and g composed with f of x ends up being just x. In other words, you get your independent variable back. So I have to do both ways. I have to do f composed with g at x. So remember what I said, write it like this and it's easier to follow. See, the f is still first and the g is still second. But because you've got things inside of other things, you're more accustomed to going inside out, all right? So you stick g of x into f of x. So here's your g of x right here. All right, so that g of x goes right there in place of that g of x. So I just took that g of x and stuck it in there. Now, what does that mean to do? Remember what that means. Everywhere in f of x that I see x, I'm going to put this right there in place of x. So that's why I have 3 minus 4. See, 3 minus 4. Oops, there comes my x. So in place of that x, I put this 3 minus x over 4. Okay? Now look what happens with this 4 and this 4. Remember, that means 4 over 1. Do you see that they would divide out? So that's just going to leave me 3 minus x. But I've got to distribute this minus. So it's going to be minus 3. And then it's going to be minus a negative is going to be plus x. So 3 minus 3 plus x. Well, 3 minus 3 is 0, and 0 plus x is x. So sure enough, when I did f composed with g of x, I got x. So check, that one worked. Okay? But we got to do it the other way. I've got to do g composed with f of x. So again, notice the g's first and the f is second. But I'm going to put f inside of g. So I'm going to go to g, and in place of this x, I'm going to stick this f into that. So see, sure enough, I have 3 minus, and in place of that x, I put 3 minus 4x. So 3 minus 4x went in place of that x. And again, I have to distribute. So that minus 3, and then minus that negative becomes plus 4x. Well, 3 minus 3 is 0. So 0 plus 4x is just 4x. And then what's 4x divided by 4? Won't those 4s go out and just leave me x? So again, I did g composed with f of x and got x. So I go back up here. I did it both ways. F composed with g and got x. Check. I did g composed with f and got x. Check. So I would say, yes, they are inverses. If one of these did not work, if I didn't get x, then I would stop immediately and just say, no, they are not inverses. Okay? So I've got to see you on a test, on your third test, I have to see you check it both ways and on your homework. And then you write down, yes, they are inverses, or no, they're not. Okay? All right, let's go look at something else you'd have to do. Okay? They're going to ask you, but let me show you this first, because I did do this. I want to kind of make sure we're clear about it. All right, so here's what I basically said. I said, notice, remember that on the last slide, we proved that 3 minus 4x and 3 minus x over 4 are inverses. Well, notice what happens if I put a 1 in f. If I put a 1 in f, all right, so notice what that means, all right? That means that in place of that x, all right, I put a 1. Well, that's 3 minus 4, and 3 minus 4 is going to give me a negative 1. So 1 went in, and negative 1 came out. So that means the point 1 comma negative 1 is a point on f of x. Remember what happens with inverses. The domain and the ranges get switched. So if 1 went in here and -1 came out, over here I would expect -1 to go in and 1 to come out. So let's see if that really happens. If you put a -1 in for your G, so right there I'm going to put -1. So 3 minus a -1. Now what's minus a negative? Isn't that plus? And 3 plus 1 is 4, and 4 divided by 4 is 1. So sure enough, -1 went in and 1 came out. So look at the points. 1 -1's a point on this one, and then flip it, -1 1's a point on that one, and that's always going to happen with inverses. What comes in here and goes out there, the reverse is going to happen over here. Let's try another one. What would happen if you put -3 inside of F? So if I went up here and in place of that X right there, okay, in place of that X right there, what if I put a -3? Well, negative times a negative is going to be a positive, so that gives me a plus 12, and 3 plus 12 is 15. So notice, -3 went in and 15 went out. So that means 3 15s a point on this graph. Well, notice what happens. If -3 went in here and 15 came out, on its inverse, I would expect 15 to go in and -3 to come out. So let's see if that's what happens. If I put a 15 in there, so I'm going to this X on this G, and I put a 15 in there. Well, 3 minus 15 is going to give me -12, and -12 divided by 4 is a -3. So do you see that when you have inverses, you can check to see if you're right, because the X and the Y should switch on the inverse, and sure enough it does. Same thing here. If the point 1 -1's on this one, -1 1's going to be on that one. So do you understand, if you had the point 1 4 on the inverse, you would have the point 4 1. If you had the point 0 2 on its inverse, you would have the point 2 0. Okay, so let's go see what happened if you have to find an inverse. All right, so here are kind of the steps for finding an inverse. It tells you the function's got to be 1 to 1. Now, you don't have to worry about that. I'll take care of that. Now, what that means is, remember, for it to be a function, just a function, you can't repeat the X coordinates. Well, for it to be a 1 to 1 function, you also cannot repeat the Y coordinates. But the easiest way to see if a function is 1 to 1 is to look at its graph. And you're not allowed to have a graphing calculator. So I'll just give you functions and tell you that these are 1 to 1 functions. So you don't have to really worry about step 1. I'll take care of that. So what you're going to do, remember, f of x is the same thing as y. So just change f of x to y. Then you're going to solve for x. Now remember, what do inverses do? The domain and range switches. So the x's and y's are going to switch. So this is the way the problem would be on your homework and kind of on a test. Find the inverse of this function. So the first thing I did was change f of x to just y. All right, so that's what step 2 means. Then it says solve for x. So I want to get x by itself. So I've got to get rid of this -6. Well, how do I get rid of -6? So I added 6 to both sides. So -6 plus 6 went out over here and just left me 4x. And I had y plus 6 over here. So I just had this right here. But I wanted just x, so to get rid of that 4, I divided by 4 here, so I have to divide by 4 there. Now those 4's go out and just leave you x. So I've got x equals y plus 6. So this is what I mean by step 3 when I say solve for x. Now, once you've solved for x, I want you to just change x to y and change y to x. So that's what I mean by switch x and y. And then this is your inverse function. It's just a lot of times, instead of putting y, they'll put this symbol I showed you on the board on Wednesday for inverse. If you want to leave it like that, that's fine. All right, so this one is your inverse of this graph. All right, look at this one. Find the inverse of g of x is x cubed plus 5. Again, I'll take care of the 1 to 1. I'm guaranteeing you that's a 1 to 1 function. So I want you to change f of x to y, or g of x, whichever. It doesn't have to be an f. That's why I used a g, so you wouldn't freak out. So you just change this to y. Now I got to solve for x. So I want just x. I don't want the cubed and I don't want the 5. So I got rid of the plus 5 first by subtracting 5 from both sides. So remember, those go out and leave you x cubed. So I've got x cubed is y minus 5. Now, how do you get rid of a cube? Don't you take the cube root to get rid of the cube? But if you take the cube root of this side, you got to take the cube root of that side. Now, let's make sure we remember, because this might be on your test, all right? You've got x cubed, all right? Now, remember, what happens when you've got a root of something? Do you remember? Let me kind of erase this for a second. Do you remember that when you change from roots to powers, that this number is the numerator and this number is the denominator when you're changing from roots to exponents? Well, what is 3 divided by 3? Isn't that just 1? And x to the 1 is just x. So that's why the cube root of x cubed is just x. All right? Now, I've got it solved for x. See, step 3, I got it solved for x. Now, all I do is exchange x turns into y, and y turns into x. Okay? So, this is your inverse. Now, like I said, instead of putting y, sometimes they'll put like the inverse of g to emphasize this thing's the inverse of g. See, right there, you wouldn't know what that was the inverse. And over here, if it was written like this, you wouldn't know what this was the inverse of. But when it's written like this, you know, oh, this is the inverse of f, and this one's the inverse of g. So that's the reason a lot of times if you look in the back of the book, they'll write it like this instead of like that. But I'm good either way, okay? So go try the homework, all right, that's up, and let me know if you have any trouble. Start working on your project, start studying for your test, all right? And I will see you on Monday. Hope you have a great weekend.